To test if a set is a solution to all three equations, we're going to have to substitute the values into all three equations. So we'll start with the first negative 1, 1, and 3. We will substitute in the first equation, so it would be x is negative 1 plus 1 minus 3 equal to negative 3. So we have negative 1 plus 1 is 0 minus 3, so minus 3 is equal to minus 3, so it satisfies the first equation. Looking at the second equation, we have x of negative 1, and we have a z value of 3. That's equal to 2, so negative 1 plus 3 is 2. 2 is equal to 2. It satisfies the second equation. Then we go into the third equation, substitute for our x value, negative 1, substitute for our y value, 1, plus 2 times our z value is 3, equal to 3, so we have negative 2, negative 1, plus 6 is equal to 3, so we have negative 3 plus 6 equal to 3. 3 is equal to 3, so it satisfies the third equation. So it satisfies all three equations. So negative 1, 1, and 3 is a solution to our three equations. So we're going to go down and check the next one, and we're going to start with the first equation, because if it doesn't fit the first equation, then there's not much sense in looking at the second and the third, because as soon as one equation, it does not fit, the solution does not fit, we're not going to carry on any further. So we substitute 1 for x, 1 for y, and minus negative 3 equal to negative 3. So 1 plus 1 is 2, plus 3 equal to 3, and we test that and we get 5 is not equal to 3. So we know that that is not a solution to our system of equations. So we're going to move on to the next one. Going to look at 1, 1, and 3. Start with substitution into the first equation. So I have 1 plus 1 minus 3 equal to negative 3. So we have 2 minus 3 to negative 3, and that will give us minus 1 is not equal to negative 3. That is not going to be a solution to our system because it doesn't fit the first equation. And looking at our last set, we'll substitute into our first equation negative 1 minus 1 minus 3 equal to negative 3. So we have negative 2, negative 3. Test if it's equal to negative 3. We have negative 5, which is not equal to negative 3. Does not satisfy the first equation, so it cannot be a solution to the set.